Hi everyone, in this video I'm going to keep going through this grade 7 exam paper. Please let me know in the comments if you have any questions. So first of all, calculate 10% of 1,500. We have calculators, but just so we have the method. So 10%, how I always remember it is this percentage symbol stands for divided by 100. Okay, because it kind of looks like a division symbol and it's got two zeros in there, so divided by 100. So what we would always do is we would go 10 divided by 100, and then we times whatever number we have. So in this case, 1,500. Okay, so all you're going to have to do, write that down so you get the marks for your workings, and then work it out. So 10 divided by 100 times 1,500. And we are going to get 150. And now it's really important, we're working in rands, so make sure you put your rand symbol in there. So 150 rand. Okay, question 2.5. John traveled by car at an average speed of 80 kilometers per hour for 4.5 hours. Calculate how far he traveled. Okay, as soon as we see this average speed, we need to know the formula. So we need to know speed, probably done this in science as well, is distance divided by time. Okay, in this case, we can see our distance, we're working in kilometers per hour. Okay, so that's what we're looking at. Our speed is going to be kilometers per hour. Okay, we are actually not working out the speed in this one. We want to work out the distance. So what we are going to do is you can change the formula before you start, so you can take this time across. So how you do it is I was dividing by time. If I take it across, I'm going to times it by time. So I'm going to say speed times time will give me distance. So you can change the formula like that at the start, or you could plug the numbers in and then change it. So now we can work this out. So distance, that's what we want. How far did he travel? So our speed was 80 kilometers. And then we are timesing that by our time. So time is 4.5 hours. We wouldn't really put it in with that. I mean, we can put it in like this. We can put it in and say 4.5 because we have calculators. What I would say is instead of 4.5, we know that 4.5 is the same as 4.5. Okay, so I would write it like that rather, just because the calculator generally likes that better. And then we just put that in. So we are going to go 80 times 4.5. So 4.5 is the same as 4.5. And we get 360. And now what's important is that we put the units, so it's distance. We are working in kilometers per hour, so it's 360 kilometers. In a question like this, you would get marks for remembering this formula. Okay, so let's just get a red pen quick. So you get marks for remembering the speed, distance, time formula, for putting in the right values, and then finally for getting the answer and the unit right. Okay, question 3.1. Fill in the missing numbers in the following number sequence. Okay, so with number sequences, my trick is I always test, can I add anything? Can I multiply anything? Can I divide anything? Or subtract anything? So I check all the operations, and then if I can't do any of those, my next trick is I check, are they square numbers or are they cube numbers? Okay, so here we can see I can't really add because 1 add 3 is 4, 4 add 5 is 9. Okay, so I don't really have adding, don't have subtracting, don't have timesing or dividing. So this one is actually going to be square numbers because we got 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. So next up, 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. And we can see we've actually kind of got a hint here. So are the numbers in the above sequence prime numbers? So they are not prime numbers, because prime numbers would be something like 2, because it can only be divided by 1 and by 2. Okay. As soon as you get something like 4, we can say 4 can be divided by 1, can be divided by 2, can be divided by 4. Okay, so that is not a prime number. So it has to only be divided by 2 things. So they're not prime numbers. They are square numbers, as we know. So that would be your hints. If you were really stuck, you're going to look at the next question and you can see, okay, well, maybe they are square numbers or cube numbers. So these ones are square numbers. Okay, study the following diagram pattern of regular octagons and then complete the table. Okay, so we've got one polygon that's got 8 sides. 2 polygons, then we've got 15 of these little side parts. 3 polygons, we've got 22. 4 polygons, well, we can then work out. So what we are going to check is what we are adding on every time here. So 8 add 7 would give me 15. Let's check the next one. 15 add 7. Okay, so that is our pattern. So if we wanted the next one, add 7, we're going to go 22 add 7 is 29. Okay, now how you get a pattern then, or how you get the sequence, is you would say whatever sequence I have. So you would say 7n. Okay, so if we had the first term, we're going to go 7 times 1 is 7. Add 1 is 8. Let's check the second term. 7 times 2 is 14. Add 1 is 15. 7 times 3 is 21. Add 1 is 22. So we can see that is actually how we get that. That's the general term. So we always go 7 times the pattern number, or 7 times the number of polygons, and we add 1. So this is our general expression, 7n add 1. So if you're struggling with that, how we always get that is we take this number that we're adding, we put that in front of the n. So that's what we've done. We put that in front of the n. And then you just got to figure out, do I have to add anything else on? Do I have to subtract anything else? So we saw every single one, we had to add 1 to get to the right number. So we know that's what we're doing then. We are adding 1. Use the given rule to fill in the missing values in the flow diagram below. Okay, so they give us a rule in the middle there. We put P in on this side and we get T out on that side. So let's check. If we put in 11, okay, this is our P value. So we are going to go T is equal to 2 times 11 minus 3. So wherever there's the P, you put the number in from the side. So 2 times 11 is 22. And then 22 take away 3 is going to be 19. On this side, they actually want us to work backwards, so we'll come back to that one. Let's do this 20. So 2 times 20, take away 3. So 2 times 20 is 40, take away 3 is 37. Okay, and then let's get a different color and do the working backwards one. Okay, so we'll use some orange. So we've got 21 and we want to see what did we start with. Okay, so this 21 is our T value. So what we can say is, so let's write it up here. T is equal to 2 times P minus 3. Yeah, we say T is 21. So 21, 2 times P minus 3. Okay, what we need to do is get that P all by itself. So if we take this minus 1 across, minus 3 across, that would be plus 3. So we're going to have 21 plus 3 is equal to 2 times P. 21 plus 3 is 24. And then we want that P all by itself, so we're going to take this 2 across. We were going times 2, we're going to divide by 2. So 24 divided by 2 is going to give me P. So 24 divided by 2 is 12. So we know then when P is 12, then we get 21. You can check yourself then. So you could just play it and just try test numbers. So you could just plug numbers into this formula and see which one gives you 21 as the answer. Okay, so in this case, we can see that T 2 times 12 minus 3 will give us 21. Okay, let's see. Calculate the value of C3 plus 12 if C is equal to 3. Okay, so in a question like this, all they want you to do is wherever there's C, you are going to put 3 instead. So let's write the formula or the expression C3 plus 12. So wherever there's C, we are going to put 3. So we're going to say 3 to the 3 plus 12. Now 3 to the 3 means 3 times 3 times 3. It's a cube number. and we've still got that plus 12. So 3 times 3 is 9, times 3 is 27, plus 12, which is then going to leave us 27 plus 12 is going to be 39. Okay, solve the following equations by inspection. So something divided by 3 has to give me 9. Okay, so by inspection, so what number could we divide by 3 and then get 9? So that would be 27. Okay, because if we did 27 divided by 3, it would give us 9 as our answer. So k is going to be equal to 27. Next up then, we've got y minus 17 is equal to 13. So something, take away 17, would give me 13. So if I did 30, let's test this, take away 17, that would give me 13. So y is going to be 30. Write an algebraic expression for the following. So x increased by 5. So increased means add. So we're going to go x add 5. Write a number sentence for the following. So 2 times a certain number p decreased by 8 is equal to 12. So we're going to go 2 times p decreased by 8. So decrease means take away. So decreased by 8 is equal to 12. Okay, the given graph illustrates the number of hot dogs sold on different school days during 1 week. So how many hot dogs were sold on Thursday? So we go to Thursday, we mark off here, okay, and then we've just got to read off across here so we can see it was 50 hot dogs sold on Thursday. On which day did the sales remain constant? So, okay, on which days? So that means on which days were there the same sales? We can see it was the same on Tuesday and Wednesday, because on both of those days they sold 20. Calculate the difference between the number of hot dogs sold on Monday and on Thursday. So the difference, that means we need to subtract. Let's go. On Monday, let's check how many we sold. So Monday we sold 40. And then on Thursday, we already said we sold 50. So if we want the difference between those, we always go the biggest, so 50, take away the smallest. And so we are going to get 10 is our difference. Okay, study the triangles marked A, B, C, and D. Complete the table below by filling in A, B, C, or D. Okay, so we want an equilateral triangle. So let's start with that. Equilateral triangle means all the sides are equal. So that's what that, okay, so all the sides are equal, all the angles are equal. So that would be C. We can see all the sides are equal. A right angle triangle, that is just something that has a 90 degrees. So we just look for that little square. Okay, so we can see that is B. It's got that 90-degree angle. And then an obtuse angle triangle is a triangle that has one really big angle. So obtuse means really big. So this one, it's got all small angles in there. So it has to be D because it's got this really big one in here. Okay, study the diagram below and answer the questions that follow. So what kind of angle is C? So C, we can see, is quite a small angle in there. So if it's a small angle, it would be acute, okay? Because you would say, oh, it's really cute, it's really small. It's acute. What kind of angle is ABC? So when they write it like this, what they're talking about is angle B. Okay, so angle ABC is this angle here. Okay, because we go from A to B to C, so it's that angle. That angle we can see is really big, so that would be an obtuse angle. Okay, let's get a different color. What angle is BDC? So we go from B 2D, 2C, we can see it is this right angle there. So that is 90 degrees. So we would say it's a right angle, and I would say it's 90 degrees. Okay, name a pair of perpendicular line segments. Okay, so they've kind of given this to us already. So because they've shown us this right angle, we know that these two lines are perpendicular. So this line, this BD, is perpendicular to DC or to AC. You could say this whole line if you wanted, because we got that 90-degree angle. So I would say BD is perpendicular to AC, or they have to mark you right also if you said BD is perpendicular to DC. Okay, let's do one more question. So T is the center of the circle. Okay, so we've got the middle of the circle here, the center. Name the parts of the circle that are listed. So these are things they always ask these, but you have to just know them, otherwise you're really going to struggle. So first of all, we've got PQ. So that is the line that passes through the center and it's the whole way across. Okay, so when it goes the whole way across like that and it passes through the center, it is called the diameter. TM then. So TM passes from the center halfway. So if it's like that, if it's halfway, it is the radius. It is half of the diameter. And then finally, PS. So PS is this line here. It doesn't pass through the center, and that one is called a chord. Okay, so 3 easy marks if you know your theory, but you have to know those because otherwise you're not going to just magically come up with them. Identify each of the figures below. Okay, so figure A is a parallelogram. Again, these are things you have to know. How we know it's a parallelogram is because we've got these two sides. So those two are parallel, and then these two are parallel. This one here is a kite. How we know that is because these sides are equal to each other, and then these sides are equal to each other. And you can kind of see it is a kite shape. And then figure C, so it's not a regular shape, but we can count how many sides it's got. So 1, 2, 3, 4, 5, 6, 7 sides. So 7 sides means it is a heptagon. But then we just need to be careful because it's not a regular heptagon, so it's an irregular. Okay, because it's not the usual heptagon shape. And then figure D, I always say this looks like a doghouse to me. So 1, 2, 3, 4, 5 sides is a pentagon. This one we could say is actually a regular pentagon, or you could just write it just pentagon. Okay, because we could see it looks like what we expect a pentagon to look like. Okay, in an equilateral triangle PQR, we've got one side is 23 millimeters. So let's just draw this triangle quickly. So PQR. And they tell us this PQ is 23. So now they want to know what are the other sides. So in an equilateral triangle, all the sides are equal. So every single side here is going to be 23. So they're just testing that you know that. So they are all 23 millimeters. And then also in an equilateral triangle, this is something else you need to know, is every single angle in an equilateral triangle is 60 degrees. Okay, it doesn't matter what the sides are, the angles are always 60 degrees. Okay, study the diagram below and then answer the questions that follow. So what is the length of DF? So first of all, let's just see what they've given us. So they have told us here that these two sides are equal. Okay, so if this side is 4 centimeters, that means this side is also 4 centimeters. So if we want DF, that length is 4 centimeters. And then the other thing that these sides tell us is if they equal sides, you can kind of imagine like a little arrow. So equal sides means these angles at the bottom are also equal. So if this one is 40, then that means this one is also 40 because these arrows point at them. Okay, so if E is 40 or is the size of F, it is also 40 degrees. Okay, study the pairs of diagrams below and complete the statements by filling in A, B, C, or D in the spaces provided. So the two shapes so we want congruent shapes. So congruent shapes are exactly the same. Okay, so they've got the same shape, same size. So we want two shapes that are exactly the same. And so it would have to be D. Okay, those ones are exactly the same shapes, even though they flip them around, but they're the same shapes. And then two shapes that are similar. Okay, so they have the same angles, same shape, but they're just different sizes. So they could be a little bit bigger or a little bit smaller. Okay, so what I would say is C, we can see those ones are quite different. They don't look like the same shape. And the same for B. These ones just don't look like the same shape. So the similar ones I would say are A. So A, we can see it's got exactly the same angles. It's just a slightly bigger triangle. Okay, write down whether each pair of triangles below is congruent, similar, or neither. Okay, so for triangles to be similar, we need all the sides to be in proportion, and we need all the angles, or we need all the angles. For it to be congruent, we need all the sides the same. We need side, angle, side, angle, or we need a right angle, hypotenuse, and a side. So what we can see here is this first triangle here, we've got this one matches this one. That's the same as that one. And this one is common. So it's the same for both triangles. So actually we've got side, side, side here. They are all exactly the same. So we can see these are the congruent triangles. Okay, because we can see they're exactly the same shapes. The second one, we can see if we look at this one, if we look at those two sides, they're in proportion. 2 times 2 gives me 4. 3 times 2 gives me 6. 1 times 2 gives me 2. So if we can do that with the sides, okay, if we can do that, if we can just times it by a number, that means they're in proportion. That means they're similar. So they've got the side, side, side. They're in proportion. They are similar. Which we can kind of see. They are the same shape. They're just slightly bigger. Okay, calculate the perimeter of a rectangle. Okay, so let's draw our rectangle. If the length is 11 centimeters and the breadth is 5 centimeters. So perimeter, I always think as plus. It was if I was walking all the way around the perimeter. Okay, so I'm just going to imagine I'm walking around a field and I'm adding up all the sides. So that means I'm going to have 11 centimeters across. Okay, so 11, I'm going to add the 5. I'm going to add another 11. And then I'm going to add another 5. So I'm going to get 11 and 11 is 22, add 5 is 27, add 5 is 33 centimeters. That is my perimeter. Write down the formula for the surface area of a cube. So the surface area of a cube is, if you have a cube, which you'll have to do with my very bad drawing, it would be you work out the area of one of the sides, and then you're just going to times that by 6 because you want all 6 sides. So the surface area, one side of a cube, the area would just be length times breadth or length times width. So you can do that for one of the sides, and then you're going to times it by 6 because you have 6 sides. Okay, let's work out the volume. So in the rectangular prism below, the length is 5 centimeters. The breadth is 3 centimeters. And the height is 10 centimeters. Calculate the volume of the rectangular prism. So the volume of a rectangular prism is always just length times breadth times height. And so we can go 5 times 3 times 10 So 5 times 3 is 15, times 10 is 150 centimeters, and then the only thing, volume, is always cubed. Okay, I think I'm going to leave it there for this video. Please let me know in the comments if you have any other questions so far, and I will post another video with the rest. Thank you for watching.